So this is Group 7's research project with Emma Lewis.
Mason West.
Adam Westrom.
And Nolan Wilson.
So first we did a mini abstract here. We used the telemarketing data set and we mostly focused on financial history factors that could impact subscription. And then, so we can see that's the first one is a default housing personal loan to have an impact on subscription. And then we took out that, and then we added age to see if that had an impact on subscription history. You can also see the longer abstracts to get into a bit more detail and results and conclusions.
So for my segment of the project, I cleaned and tidied the data. First, I downloaded the data set from the website and then converted it into a spreadsheet. And I labeled it as a raw data and working data, and then I created a backup. From there, in the data dictionary, I created a data dictionary, and the only variable I renamed was I changed Y to subscribe just for better clarity. And then for the variables we used age, which is just the age of the respondent, and put it as a number. We used default, which is just if the respondent's credit is in default, which is just yes or no or unknown. We used housing, which is if the respondent has a housing loan, which is also yes, no, or unknown. And then loan, which is if the person has a personal loan, yes, no, or unknown. And that was to predict the subscribe, which just has the person subscribed to a term deposit. And we trimmed our data set, or we filtered our data set to just age range from 18 to 25, but then we decided that was too narrow of a range, so then we extended it to 18 to 30 and created this .csv file, and also we trimmed the data to just the 5 variables that we were looking at.
The first 2 graphs are the exploration graphs. The first graph shows the relationship between age and the proportion of those who are subscribed. As the age of the individual increases, the proportion of those who are subscribed decrease. This suggests that younger individuals are more likely to subscribe. The next graph facets the subscribed variable to show relative distributions of the percentage of each age takes up on the graph. Both graphs are increasing, but those who are not subscribed are increasing faster. One takeaway is up until the age of 24, those who are subscribed take up a larger relative proportion than those who are not subscribed, but after age 24, not subscribed begins to take over. The third graph shows the difference between those who are subscribed and not subscribed. We can see that there is a larger proportion of those who are subscribed and have not defaulted than those who are subscribed and are known to have defaulted. The fourth graph facets the loan variable into has a loan, unknown if there is a loan, and does not have a loan. Then shows the proportion of subscribed by housing. As we can see, the proportions are all very similar, suggesting whether if a young adult has a loan or not. It doesn't substantially affect the chance they have a house or are subscribed or not. The last graph, to make it, I combined the 3 variables using pivot longer and then faceted by the cases. So this graph shows the different distributions of the default housing and loan variables. There is no noticeable difference in the proportions of the graph.
In terms of using predictive modeling to predict the outcomes of new data, I did both a CART model and a random forest model for for the explanatory variables used in both research questions. Among all of these models, both of the random forest models performed fairly worse, actually, in comparison with the original CART models that I had made. I would definitely say that among all of the models that I created, the first model, the first CART model that I made to tackle the first research question definitely performed the best for predicting the end subscribe variable. Though I would also say that the model that I used, the CART model that I used for the second research question was also fairly accurate as well. Furthermore, in addition to the CART models being the most accurate, I would say that it would definitely be useful to cross-validate this across multiple different data sets because of the problems with overfitting that are caused by classification error. Just in general, especially with CART modeling, it's really easy to overfit to your data set, even whenever you're using a test data set to try to cross-validate a little bit. Classification error can definitely cause overfitting. And so I would definitely recommend for future modeling experiences, we try to cross-validate with other data as well. Yeah.
So if we look at our conclusions, so the first thing, the best predictive model, we already said, was that first CART model for the first question that included housing loan, personal loans, and default on loans. There were some worries about overfitting. There were some different measures of error prediction error in between the different models, but ultimately that's what to say.
Some possible extensions of our research could be by using more measures of financial history, such as income, such as just other ways to show the financial history of the individuals and see if those have an impact on subscription rates, along with using different age groups to see if those trends change. And as always with data, a large and more diverse sample would help with future investigation.
As for some possible project weaknesses, some of the variables that we chose didn't actually yield high levels of connection to our response variables. Specifically, the default loan and housing variables didn't demonstrate a super strong connection. And so since all of the variables are categorical except for our H variable, there was definitely a limit on the types of models that we could use and the different kinds of graphs that were available to demonstrate connections between the models. Otherwise, the unbalanced percentage within subscription didn't help to yield any great results from our statistical analysis either.
Any other main takeaways? This data and the variables chosen did not make strong models or predictive power. It seems as if these variables may be connected, but our data and models are not strong enough to state that for certain.